In progress.
Last step change. Okay. Well, friends, online candidates are my audible. Can you hear me? Online candidates, am I audible?
Yes, Prashant.
Okay, fine. So, friends, well, let's continue with our discussions. Yesterday, we explored what's a roles concept in Ansible. So that concluded our discussions in Ansible, and effective today, we are good to get started off with a new tool, Kubernetes. Welcome to the most boring tool, the most annoying tool in DevOps, Kubernetes. Meaning, it's interesting if you pay interest. If at all we skip somewhere, you find what's a lot more content following and pretty intimidating. A tool అర్థం చేసుకున్నంత వరకు ఏం ప్రాబ్లం లేదు. You find it interesting, but the time you are disconnected from for some time, what happens, more and more information we keep adding, that is where the tool becomes somewhat complicated. Okay, so I'll try to keep myself updated with the tool, make sure that you follow along too. So let's continue. So what is Kubernetes? We'll begin off with a question. What is Kubernetes? Yeah, friends, what exactly is Kubernetes? A recording. Yeah, it's recording. What is Docker Swarm? Docker Swarm. Container orchestration tool. So do Kubernetes too. Kubernetes is also a container orchestration tool. What is container orchestration? Make sure that the containerized applications are always available. You want to ensure that containerized applications are always available. So we got multiple container orchestration tools like Docker Swarm, Apache Mesos, Red Hat OpenShift, and Kubernetes. And organizations are expecting people with more Kubernetes exposure rather than other tools. Of course, some organizations, based on their project, based on their project weightage, they're choosing different tools. But mostly, priority is given to people who are, having good amount of knowledge in Kubernetes. Why Kubernetes? Kubernetes is a tool. It is from Google platform, Google, and later Google, they donated this tool to CNCF, Cloud Native Computing Foundation. It is written in Go language, and it is the tool that is compatible for multiple container types, multiple container technologies. Docker Swarm only for Docker containers, whereas Kubernetes, on the other hand, it is for the containers that are created with any technology, like Rocket. Likewise, we got container D, we got Cryo, CRI-O, LXC, and so on. These are all the container tools that are compatible, and these are all the container tools which are on which Kubernetes does container orchestration. Okay, that is the reason we're focusing more on the Kubernetes. Docker Swarm lo manam what is what container orchestration and internet is maintaining one single container on one machine. It's not an idea. It's not ideal. And what we're doing, maintaining container application in a distributed environment. And okay, server application unte, if the application crashes, nothing to do. Application fails. If we maintain the application, in a distributed environment, what happens? Even it fails on one server, it is pretty much possible to make the application available on a next server, another server. So, container orchestration concept, when you get any questions, it's all about high availability. No matter what concepts we do in Kubernetes or Docker Swarm, when the concept is all about container orchestration, remember that this is all about high availability, making the containerized application highly available. Okay, so discussion everything leads to ultimately make a result in the day. It's all about high availability, right? Like all the roads lead to Rome. All the discussions in Kubernetes, Docker Swarm, Mesos, OpenShift, all these lead to make an application highly available. End user your application, it should always be running, no downtime. Even though there is downtime, we have to reduce that, and we have to make sure that the application is having reduced outages. So, my discussion, whatever the concepts we learn, everything revolves around these 4 business needs. What are they? Continuous delivery of a product, ensuring quality, cost-effective solution, and reduced outages. Continuous delivery and quality. We're doing this with a CI/CD, Jenkins, CI/CD activities. So continuous delivery and quality issues. Cost-effective nature. We are automating things. We're relying on Linux servers. We are relying on the cloud, and we're finding cost-effective solutions. Next, the reduced outages, meaning the application should always run. No outage, no downtime at all. Even though there is a downtime, we got to reduce it to the very minimal level. If application fail, it should run again. It should get back to normal within a very short time. Now, our discussions on Docker Swarm and Kubernetes are to make sure that the application has no downtime or reduced outage. Okay, and it's all about making your application highly available. Yeah, friends. So now let's jump in, understand Kubernetes in detail. I'm not going to give you an overview. Get a Docker Swarm and already like what is what's the rolling update, how to scale up things, scale down things, right? Load balancing, like you can reach on to an application from server 1 IP, server 2 IP, server 3 IP, etc. Cluster management also we covered in Docker Swarm. Okay, server manager fail, I think. Other manager, node apply manager we already discussed at that time. What are the advantages, benefits of container orchestration? Now let's understand Kubernetes architecture. This is the tool I said at the beginning. It has some hectic architecture. Okay, and the structure of Kubernetes, if we were to understand, it is a bit complicated, meaning it's a bit tedious. And then lot of objects in the Kubernetes architecture. We got to understand their behavior. We got to understand how Kubernetes cluster actually works. So let's give a try. Let's get going. So first, in a Kubernetes architecture, you have a node which is called as a master node. Kubernetes cluster low. And first server ended a master node. Then we have worker nodes or slave nodes. So now say friends, I got let's say 2 slave nodes. I'm talking about a 3-node Kubernetes cluster. So initially, let's say 1 master and 2 worker nodes, or 2 slave nodes. Now in a Kubernetes cluster, In all these nodes, what should be in common? What should be common? Java, na? Kubernetes and Kubernetes cluster low. What do you think, is the tool that is required? Okay. ఇంకా ఏ టూల్ ఉండాలి మనకి? Python. Okay. Next. Kubernetes is a tool for container orchestration. Container orchestration చేయాలంటే మనకి ముందు కంటైనర్ టూల్ ఉండాలి. So never say Docker or don't say Docker for now. Runtime అండి, కంటైనర్ runtime అనండి. ఎందుకంటే it's not just about Docker. As said before, Kubernetes can manage to do container orchestration on any of the containers that are created with Docker, maybe Cryo, LXC, Container D, and so on. So first a container tool undalandi. Everywhere you should find a container tool. That may be Docker, that might be Cryo, that might be LXC, we don't know. Okay? So first and foremost, you should have a container tool available in your cluster. Master lono, slave 1, slave 2. In all these nodes, there should be a container tool available. Followed by that, on the master, we got to have some components. కొన్ని components ఉన్నాయి. What are they? Let's understand. First, container runtime. ఈ green box వచ్చేసి container runtime here too, and here as well container. Next, now we get going on with what are the other objects available. First object వచ్చేసి first place we should have something called API server. Kubernetes Kube API server. We got to have this object. Followed by that, controller manager, scheduler. Next, we got to have controller manager and etcd key value data store. API server, scheduler, controller manager, and etcd key value data store. It's a database kind of thing. Okay, key value database. These are the major objects you should present on a Kubernetes master node. And coming to slave nodes, we have two major components in slave nodes. What are they? Kubelet and Kubelet and kube proxy. Two things, kubelet and kube proxy. So these are the components which should be present in your Kubernetes cluster. అంటే మనం ఇప్పుడు ఇవన్నీ కాన్ఫిగర్ చేసుకుంటూ రావాలి. If we set up a cluster, kubelet and kube proxy. Kube proxy. Okay, these are the components we got to configure on a Kubernetes cluster. Master lo ee components undale, slave lo ee components undale. And now how to write your manifest. So let's say I want to deploy a container application. I want to deploy a container application. That application should run all the time. So now how to write your how to write your configuration. Means in Kubernetes, you can write your configurations in two different formats. One is through a UI, the user interface. Manki Kubernetes dashboard and a concept. Kubernetes dashboard. And a Jenkins lane UI tone, you can do some things. Likewise, through a CLI, command line interface. Command line interface to Kubernetes active shell. There is a component called kubectl, kubectl. With that component, you can do things either by writing some commands directly or with YAML scripts. Answer line ad hoc commands, playbooks. Likewise, through a CLI too, you can do things. YAML files write you, commands write you, and then you can create your your configurations of your applications, container applications. But now, when you write your configuration either through UI or through a CLI, Kubernetes ఎట్లా అర్థం చేసుకుంటుంది and how it lets your application create means whatever the request is written in whichever format, maybe UI or CLI, first the information is routed to a master node. అంటే మీరు ఈ the configurations, Kubernetes dashboard or CLI, you can configure them directly on the master node itself, or maybe of a third server node kuda meer Kubernetes cluster ki connect avachchu. Okay, you can maintain your entire cluster different, and from another node and my laptop node I can run Kubernetes commands. If I am doing so, I have to make sure that there is a component called kubectl installed on my local machine, and I should get the master nodes details added on my local machine. Then from my local machine, I can write Kubernetes clusters targeting the master. So you write a command or you write a script, a YAML file, which we call it as a manifest. మన playbooks అంటాము Ansible. ఇక్కడ వచ్చేసి manifests or definition files అంటారు. Kubernetes definition files or manifests. So you can write your application pods, everything in a manifest format or a definition file. మీరు రాసినప్పుడు through a UI tool, you can do things. The very first object that is API server. So API server is called as the gateway to your Kubernetes cluster. Okay. First foremost, what happens? The request is received by API server. Okay. And what does an API server do here? Once the request is received, or whatever the configuration you're writing, once it is received, now API server adds that information into something called a etcd key value data store. API server ranges whatever the whatever the application you want to create, that application's information is persisted. The API server ranges it persists the information. API server persists the information So API server does this. It receives the information from your manifest file. It processes the information and adds that information in key value data store etcd. Now what happens from etcd? The information is picked by something called a scheduler. Next time out, a scheduler picks that information. What are the entries that made into etcd key value data store? Now a scheduler kicks in and gets that information. So just understand this. etcd tarvata scheduler gets the control. Now what a scheduler does then means scheduler now communicates with the kubelets. Scheduler now talks to the kubelets of your worker nodes, and it assigns a task to one of the kubelets or both of them based on your requirement. Okay, application or container application creates here. One server is sufficient, but what a scheduler does, it reaches out to the kubelets and assigns a task to them. And FCFS first come first served, a sort of assignment out, meaning which kubelet responds faster to that kubelet, the task is assigned. Now kubelet, once it receives a task, what it does, it interacts with the underlying container technology. Well, kubelet respond in the this kubelet talks to the underlying container technology and creates the object for which we have written a manifest, or for which we have written a command, or whatever we doing with our dashboard. So then the process under. Okay. Now what happens? Container interacts with the kubelet and container application gets created on those servers. Okay. So this is what. Now again, let's say kubelet also we discussed. What are the other steps still remaining? Controller manager and kube proxy. So controller manager, what it does? Let's say you gave a task to create 5 Nginx applications. You gave a task create 5 Nginx applications, Nginx container applications. Now scheduler, it assigned a task and 2 containers created here and 3 containers down below. And remember friends, by default, containers are not created or container applications are not created on the master. And the configuration రాసినప్పుడు Docker Swarm lo aithe manager node kuda active participant avutadi. But here, no. Kubernetes lets the configuration, whatever you create, everything is happening only on the slave nodes, not on the master. And by default, atla oka command, what say, constraint add ayi undi. If we wish to, we can change that, but remember this. 5 Nginx apps create cheyamanar. Now let's say 1, 2 here, and 3, 4, 5. But for some reason, one of the application failed. 4 only, but the desired count is to be 5. Now this is where a controller manager kicks in. A controller manager ranges always ensures whether the configuration, whatever is written, that is up to the mark or not, that is fulfilled or not. If not, this controller manager kicks to the scheduler. Controller manager assigns tasks to the scheduler. The desired state is this, but the desired state is not fulfilled. What are you doing? Go ahead, assign task to the kubelet and get the servers to the desired state. Okay, so this way we got controller manager. Yep. And just giving a simple overview, and way too technical, because first we should understand. Later I'll add some more technicalities, like what exactly is in etcd, everything. And a Kubernetes as a tool, it has its own certification. Man explore cheyalante, meaning to go deeper and deeper and explore everything. Prati object ki ikkada marla lot of functionalities assign ayi untayi. But let's try to get the core idea of these different objects. Okay. Yeah. Now, what exactly is a kube proxy? Manki last object on the kube proxy. What is this thing? Kube proxy. Container applications create end users trying to access that application. Now, who would write about an end user request to the respected application, which is residing in slaves? So there you find kube proxy doing that. Okay. The application on the end user is trying to reach to that application. Where that application is residing, which server or which application, there are 3 or 4 at the same time. To which container the application should be routed to, all that are taken care by kube proxy. So these are the different objects, and this is the architecture of Kubernetes. Miru web kelli chudandi, just go give a try. Kubernetes architecture. You find the same majority of the images, you get the same result, exact result. Control plane and master node control plane. Yep. API server, scheduler, controller manager, etcd cluster, kube proxy, kubelet, container runtime. Kube proxy, kubelet, container runtime. Like this image. Have a look. Developer or operator. What he does, he writes some code or he writes some command that is reached to the API server. API server now, it adds information to etcd, control manager, scheduler. Okay, scheduler kicks into action, assign the tasks to the nodes here. So if we and marla ikkada kuda, don't get confused with the images here. Make sure that you follow or you go through some reliable sources. Because ఎవరికి అర్థమైనటువంటి images create చేస్తున్నారు. So, but mostly the object types I'm trying to show you here. Mostly the object types here you find are API server, controller, scheduler, say cluster store and schedule. It's etcd actually. etcd key value data store or a cluster store. And here we got nodes, and within nodes pods are created, etc. So this way we got Kubernetes cluster. See, student, this is way much closer to us. This image is very much closer to what are we discussing now? So through a user interface or through a CLI. CLI, I think there should be a component called kubectl. And control jumps to the API server, scheduler, control manager, etcd. And now worker nodes or slave nodes. On the worker nodes or slave nodes, we got kubelet and kubeproxy. On top of that, we got Docker here, but you could say container runtime. Container runtime is present. With the help of container runtime, the containers are created. Okay, this is a quick overview of Kubernetes tool. Now let's understand the setup process of Kubernetes. And Kubernetes setup process, it requires some good amount of CPU, RAM, storage, for example. So Kubernetes cluster requirements. Kubernetes cluster requirements choose the meru. What is it saying? To run a production grade Kubernetes cluster, each node that is to be part of Kubernetes cluster should have one CPU, 4 GB of RAM, at least 40 GB of hard drive, and 20 GB, etc. So meaning T2.micro is not going to work. T2.micro sentosunayani manki 1 CPU, 1 GB of RAM, 8 GB of hard disk. Right? So T2.micro doesn't fit for Kubernetes setup process. So over here, just have a look. Before you begin, compatible Linux host. The official side of Kubernetes will ship 2 GB of RAM, 2 CPUs or more. Okay. So in order to configure Kubernetes cluster, at least we need at least 2 GB of RAM and 2 CPUs per server. So if I go to my AWS account and create, what happens? I get charged because it is not free. T2.micro, T2.medium is called. So when we create T2.medium, what happens? We get charged, right? So that is where the plan we have for you is we rely on AWS Cloud, Google Cloud. Google Cloud Platform and they're offering a cluster which is managed, meaning you don't need to create anything. Installation we set up Ansible. Process choose to achieve. We did set up Jenkins master slave architecture. Jenkins CI/CD architectures. Our setup process and steps follow. But now for Kubernetes, you can create Kubernetes clusters in 2 ways. One is managed cluster, and the second one is self-managed cluster. Okay. So now what we do, we adapt to the service offered by Google Cloud. Google Cloud one service. Kubernetes cluster as a service they're providing. So all we have to do is just opt for it. So some servers are created and some Kubernetes cluster is formed and it is available to us. And VDChat cluster it is very much decent. We get at least 4 GB of RAM per server and 2 CPUs. And the exact requirement is available for the cluster. And the good news is Google Cloud Platform, when you enroll it for the first time, meaning when you add your credit card details and activate it, for the first 3 months, they provide you with $300 of free credit. 3 months long, $300 you share. And online shopping share only to that amount is pertained only to your Google Cloud account. And at 3 months lo mere a service use chesi meekana bills generate aithe they deduct the amount from the $300 credit. Okay, it's available only for 90 days. Once you add your credit card or debit card details. But the drawback with Google Cloud, drawback 3 months tarvata you're still working on and some money you're charged. Google Cloud Azure Cloud they deduct money from your account and then update you. We deducted this amount from your account. And the resources properly use no problem. So if you want to get a full-fledged overview of Kubernetes, make sure that you create a Google Cloud account. Create your name with just your email and password you will add, and you gain access to it. And then what to do? Jump to మన ఎంతవరకు క్లౌడ్ షెల్ యాక్టివేట్ చేయడం ఇది చూసాం అంతే ఫ్రీగా. బట్ నౌ we keep going down here. చూడండి ఇక్కడ కింద Kubernetes engine. And all you got to do is choose clusters. Choose clusters and yeah, friends. Now over here, this is Kubernetes create clusters page. And find చూడండి create an option. Just select that. And here we are asked the autopilot cluster and standard cluster. Two types of clusters. Google Cloud is offering this. Autopilot cluster and based on your requirement, the cluster size is reduced. And make usage number, Google Cloud adds more servers for you. And when not required, it won't add anything at all. So resources are scaled according to your requirement. Automatically. Standard and we manage our own Kubernetes cluster. So let's choose standard and click OK. Click చూడండి. If you create a Kubernetes cluster at Google Cloud level, the estimated monthly charge is $158 per month. And a cluster we create chesi, వదిలేస్తే around $150 you get charged per month. Now, what we got to do is just leave everything as is, default వదిలేసేయండి. Just click create. But in my case, I'm getting an error. And mere create chesthe meeku avvachu. But in my case, I'm getting some error like insufficient regional quota. And because I'm already consumed my free quota. So meeku raavachu, but for me, it's not allocating any resources or storage. So what I do is, in my case, I'll go and use a setup plan and go with my first cluster, an affordable cluster to experiment with. Let's select this one and say create now. What happens? A server gets created. Sorry, a cluster gets created. Number of nodes, 3 nodes to the cluster form out. In your case, when you go with standard and create, you get a cluster with 3 nodes only. 3 nodes is the and total CPUs which is 6 ఉంటాయి. Each node has 2 CPUs and overall RAM which is some 12 GB కనిపిస్తుంది. And each server equipped with 4 GB of RAM. In my case, they're restricted. I think because of May, I added some restriction here. Don't exceed my usage of more than 500 rupees at all. So that is where I'm not getting assigned with 4 CPU and 4 RAM. But it takes some time, things. The cluster form chain, it's not the case that cluster forms like a flash in Docker containers like. It takes some time, around some 5 to 10 minutes per minute. అదే మీరు ఓన్ గా Kubernetes cluster setup చేసుకోవాలంటే AWS లో the way how we do EC2 instances, Ansible cluster set చేసుకున్నట్టు అట్లా చేయాలంటే at least 40 minutes it will take. At least 40 minutes only to the cluster setup. Okay, but అంత కష్టపడి cluster form చేసుకొని మళ్ళీ servers స్టాప్ చేస్తే సరిపోదు. We have to delete them if you don't want to get charged. మళ్ళీ delete చేసి మళ్ళీ సెటప్ చేసుకోవడం కష్టం కాబట్టి I'm showing you this quick example. Okay, quick approach. You can go with setting up your Kubernetes cluster this way. Atlane, if you have installed Docker Swarm, how many of us installed Docker Swarm? Yeah, friends, how many of us installed? Sorry, Docker Desktop. I'm sorry. Install is the slow అయిపోతుందా? Yeah, of course. ఇంకా స్లో చేయాలంటే మీరు ఏం చేయాలి ఇక్కడ? ఇంకా మొత్తానికి డెడ్ అయిపోవాలి సర్వర్ అంటే ఇక్కడికి వచ్చి Kubernetes అని చెప్పి ఇది ఎనేబుల్ చేసుకోండి. ఇంకా మీరు కీబోర్డ్ ఎట్లా మౌస్ ఎట్లా మూవ్ చేస్తారంటే అది గంటకి మూవ్ అవుతుంది ఇట్లా పిక్సెల్స్ కనబడతాయి. But yeah, a Kubernetes cluster you can form on your local machine too, just by setting up or enabling this Kubernetes. Enable Kubernetes. ఉందండి అది కూడా ఉంది అదే చూద్దాం. There is a site called Play with Kubernetes. మనలాంటి గూగుల్ కోసం say play with Kubernetes and see when you are working in an organization మీరు అక్కడ ఇవన్నీ సెటప్ చేసుకుని ప్రాక్టీస్ చేయడానికి టైం పట్టేస్తుంది కదండి. దట్ ఈస్ వేర్ సమ్ ఆఫ్ ద వాట్స్ ఏ ప్రొఫెషనల్స్ దే కేమ్ విత్ దీస్ సొల్యూషన్స్. అంటే ఫేస్బుక్ ఎట్లా ఓపెన్ చేస్తారో అట్లా ప్లే విత్ Kubernetes అండ్ యూ కెన్ ఎక్స్పెరిమెంట్ విత్ ఇన్ దాట్ సర్వర్ విత్ ఇన్ బ్రౌజర్ ఓన్లీ. బట్ ఆఫ్టర్ 4 hours వాట్ హ్యాపెన్స్ ఇట్ విల్ ఎక్స్పైర్. సో అట్లా మనకి వాట్స్ ఏ సమ్ ఆఫ్ ద talented individuals they develop these some Docker captains like Kubernetes community వాళ్ళు చేసిన అప్లికేషన్ ప్లాట్ఫామ్స్ అన్నమాట. All we got to do is click login here, play with Docker అయితే Docker credentials తోటి లాగిన్ అవ్వాలి. Play with Kubernetes we have to GitHub credentials in Docker. Anything is fine. I'm choosing Docker in my case and I go with start. So what's happening? Student ఇక్కడ countdown timer begin అయిపోయింది 3 hours 59 minutes and now all you got to do is add new instance. అయిందా? యాడ్ అయిందా? No, not getting added because even this platform they know that Kubernetes cluster form చేయాలంటే a server requires more CPU, more RAM. So now if they have adequate resources అంటే ఈ platform ఫ్రీగా ఉందనుకోండి, they assign us some servers and we can practice. But ఇది ఎట్లా ఆపరేట్ అవుతుందంటే బేస్డ్ ఆన్ ద డిమాండ్ FCFS. ఫస్ట్ ఎవరైతే ఆక్యుపై అయ్యి కొన్ని సర్వర్స్ క్రియేట్ చేసుకున్నారో ఫర్ దెమ్ ద ప్రయారిటీ ఇస్ గివెన్ అండ్ నెక్స్ట్ పార్టిసిపెంట్స్ కి ఒకవేళ రిసోర్సెస్ ఉంటే వి గెట్ వాట్స్ ద సర్వర్స్ క్రియేటెడ్. బట్ నౌ వాట్స్ హ్యాపెనింగ్ ఇస్ నాట్ గెటింగ్ పాసిబుల్. But this is a platform and even here you can create your Kubernetes cluster like the way we did with the Docker Swarm. ఒక నోడ్ యాడ్ చేస్తారు, దాంట్లో మీకు 3 కమాండ్స్ ఇస్తారు. ఇనిషియలైజ్ Kubernetes, యాడ్ అండ్ నెట్వర్క్ మెజర్. ఆ 2 కమాండ్స్ ని ఒక Kubernetes మాస్టర్ లో రన్ చేస్తారు. When you run the commands, you find a token వస్తుంది. Go to copy the token, add 2 more nodes and include the token in the next available nodes. So itla you can set up Kubernetes cluster in this platform too. Okay, అదే మనం ఓన్ గా సెట్ చేసుకోవాలి అంటే Kubernetes it takes a lot of time. Takes a lot of time. And Google Cloud Platform, see the platform, it's automated. Automation kind of platform around some 5 to 10 minutes తీసుకుంటుంటే when we got to do things manually, you have to run all these commands. GitHub.com ఇక్కడ మనకి కొన్ని కమాండ్స్ ఉన్నాయండి. ట్రై చేస్తారా Kubernetes సెటప్ మీరు? Ansible cluster setup ఇది. This is Terraform settings and yeah, this one. Prerequisites, 3 Ubuntu servers create చేసుకో. One server should be manager with 4 GB RAM and T2.medium. అయితే వర్కర్స్ కూడా లేటర్ వెర్షన్స్ ఆఫ్ Kubernetes లో you got to scale them to 4 GB RAM and 2 CPUs. లేదంటే పర్ఫార్మెన్స్ కొంచెం daunting గా ఉంటుంది. Not to that extent. Now open the required ports. Kubernetes కి కొన్ని ports ఓపెన్ చేయాలి మనం. What are they? Let's find out. The ports and protocols we got to open are these 6443, 2379, 2380, 10250, 10259, 257. అట్లాగే కంట్రోల్ ప్లేన్ అంటే మాస్టర్ నోడ్ లో ఈ పోర్ట్స్ ఓపెన్ చేయాలి, వర్కర్ నోడ్స్ లో ఈ పోర్ట్స్ ఓపెన్ చేయాలి 10250 అండ్ 30,000 to 32,767. These are the ports we got to open. Followed by that, what else to be done? What else to be done? Let's find out. Update the package manager. ఒక్కొక్క సర్వర్ లో మీరు చేయాల్సిన యాక్టివిటీస్ అంతా కామన్ ఫర్ మాస్టర్ అండ్ స్లేవ్స్. అంటే ఈ కమాండ్స్ అన్ని కూడా till this part, all these commands are same on master as well as slave nodes. మీరు ఏం చేయొచ్చు, AWS డిస్కషన్ మొన్న రీసెంట్గా జరిగినప్పుడు చెప్పాను, ఒక సర్వర్ లో మీరు ఈ కమాండ్స్ అన్ని రన్ చేసేసి యూ కెన్ బిల్డ్ an image క్రియేట్ చేసుకుని ఫ్రమ్ దాట్ ఇమేజ్ యూ కెన్ క్రియేట్ 2 వర్కర్ నోడ్స్. అంటే మళ్ళీ ఈ కమాండ్స్ ఒక్కొక్క సర్వర్ లో రన్ చేసే బదులు. సో అడాప్ట్ ద షార్ట్ కట్స్. Followed by that, you got to jump to master node and e commands which is only on the master you have to run them. Only on the master node you have to run. Then you can get going down and say some of the commands you got to run on the worker nodes. Simple ending. That is it. A Kubernetes cluster gets formed. But if process ante cheyadani get least of 40 minutes. Instead of that, if you want to practice Kubernetes on Windows platform only, enable Kubernetes, apply and restart. Kubernetes cluster gets formed and you get restarted. And a cluster అనేది form అవుతుంది ఇక్కడ, which is on this node with the help of Docker containers. అంటే వర్కర్ నోడ్స్ ఒక 2 Docker containers లో క్రియేట్ అవుతాయి. Kubernetes master ఒక కంటైనర్ లాగా. Yeah. So that way you can maintain a Kubernetes cluster. But we go with this approach only, friends. Google Cloud Platform make easy and okay, now see what happened. In my case, it assigned me a cluster with only 3 nodes, where the number of CPUs are 3. Memory ఎంత వచ్చిందండి? 5.1 GB. అంటే whatever is required, at least 1.5 GB of RAM ఉంటే చాలు ఒక్కొక్క సర్వర్కి. But they say 2 GB. But now it assigned me to the and కొలత చూసి కరెక్ట్ గా అంతే RAM assigned in the server. Exactly resource utilization happening to the very least level in my case. But make a problem ఉండదండి, because mine is already expired. My account is already expired. That's why they're not offering me a huge cluster. Now, how to connect to this cluster and how to perform things? ఇప్పుడు ఈ క్లస్టర్ కి ఎలా కనెక్ట్ అవ్వాలి? AWS లో అయితే SSH వెళ్ళి కనెక్ట్ అవుతుంది, కరెక్ట్. బట్ ఆన్ గూగుల్ క్లౌడ్ ప్లాట్ఫామ్ మీకు ఉన్నది ఏంటంటే యూ ఆల్రెడీ గాట్ అ క్లౌడ్ షెల్. త్రూ ద క్లౌడ్ షెల్ ఓన్లీ యూ హ్యావ్ టు కనెక్ట్ యువర్ క్లస్టర్. అండ్ ఇక్కడ కనెక్ట్ అవ్వడానికి ఇట్స్ నాట్ వన్ సింగిల్ మెషిన్. ఇక్కడ మనకు ఆఫర్ వచ్చిన 3 servers. ఆ 3 servers Kubernetes cluster connect అవ్వాలి అంటే we have to jump here, click on this ellipsis and connect అంటారు. Got to copy this command and then run the command over here. Authorize చేయండి. That is it. Now we are connecting to the Kubernetes cluster. So kube config entry generated for my first cluster 1 second. Now we are good. We are connected to Kubernetes cluster. అయితే ఇక్కడ మీకు ఒక చిన్న క్యాచ్ ఏంటంటే, when you create a Kubernetes cluster, you should have a master node and worker nodes, right? Now, what are the cluster we created or Google offered us? What happens is all the 3 nodes which are created, all the 3 nodes that are created are workers node. We will create 3 nodes కూడా workers. Then what about master? What about the master? And then from where you connected to these workers, that node plays the role of master. And then if cloud shell there, your cloud shell itself acts as the master. Remember, if only Google Cloud, other platforms will be getting everywhere we find we configure a platform, you have this area. Right. So now this is the master node. Or it acts as a master node. Now, if you run the commands, like let's say kubectl get node. You should know where you are finding the role as master or control plane here. Control plane, master, and route level. Roles and none and us. Whichever servers got none as a role, they are all workers. Remember. Okay. Now, master is nothing but this node. Okay. Kubernetes master is nothing but this node. Now, let's say kubectl get nodes -o wide. What is this command? The command name is the 3 servers Google Cloud offers. These are workers. Status ready. Eప్పుడు create any version of it. What is the IP address of these nodes? Public IP, private IP of the nodes. If you want to get some additional information, we're getting some more additional information, not just the name, status, roles, age, version, name, status, roles, age, version, tarvata, internal IP address, and then private IP address, external IP address, meaning public IP address, OS image, and these servers, what are from which operating system these servers are created, OS image, kernel version of control, a server sector, kernel version. Next step, container runtime. What is the container runtime here? Docker. Container D is the runtime. Container D configured. Image వచ్చేసి operating system image వచ్చేసి container optimized OS from Google. Meaning nothing but mostly Ubuntu servers. The same container optimized OS from Google. And yeah, that is it. Public IP, private IP, Sunny good of where we go with -o and y. Okay. So kubectl get all, get nodes. Is the command ready to get the details about your cluster. Okay. So don't freak out here because there is no control plane. Control plane under IL commands, but this cloud shell is acting as a control plane or master. Yeah, we clear? Online candidates, are we clear? Following along? No? Yes, maybe. Yeah, well, friends. So now, Kubernetes lo manaki konta discussion untundi atlane hands-on untundi. So we have to go parallelly. Concept తీసుకుంటే దాన్ని explain చేయాలి అట్లనే we should go do a hands-on. So today I would like to discuss an important concept in Kubernetes, which is namespace. Namespace concept. What is a namespace in Kubernetes? What is a namespace? Namespace and let's find out. So friends, let's say I'm a web developer and I'm assigned with project. And what I do if I'm assigned with, let's say, some 2-3 projects, 2-3 different clients. Now, what I do if I'm working on project 1, I maintain all the data of that respective client in a separate folder, and all the project maintained in a different folder. Project 2, I maintain in a separate folder. Project 3, separate. If not, what happens? Let's say I started with project 1 and directly creating files on my desktop of project 1, project 2, project 3. That looks ugly, right? Ugly, and managing things become extremely difficult for me itself. For me, let's say if I want to collect all the project one files, it becomes extremely difficult when there are multiple files which are all maintained in one single location. They are not organized properly. So now, why we are talking about this means in Kubernetes 2, when you are working for some projects, what should you do? You have to create some objects and bind your application into those objects. మనం ఏం మాట్లాడుకున్నా Kubernetes లో it's all about what they making your application highly available. So now, if I want to make an application highly available, what should I do? If I want to make an application highly available, I have to work with some Kubernetes objects. We're going to work with some Kubernetes objects. And let's say for project one, I'm creating some objects. For project two, I'm creating some more objects. If all of them are maintained in one single location only, that becomes extremely difficult for us to manage. That is where now what we do is we got to understand that, say in Kubernetes, a component or something called a namespace. What is a namespace? A namespace gives you that sort of arrangement. It allows you to maintain your applications of one project in one namespace, or applications of another project in another namespace, a third project in a separate namespace. To organize things, to organize and to isolate things of one project to another project, what you do, you create namespaces. But in Kubernetes, there are kubectl get ns and there are 4 namespaces. What are they? Default, kube node leaves, kube public, and kube system. Currently, MySQL container create చేసినప్పుడు when we went into the MySQL database, pure databases అంటే మనకు already కొన్ని databases by default ఉండేవి, right? MySQL, performance underscore schema, ఇట్లా కొన్ని databases. Likewise, we initialize Kubernetes and by default we find these 4 namespaces available. And what are the objects you create for any project? The default namespace అనేది occupation system. Any object you create in Kubernetes, this is the namespace in which everything gets called, everything gets added. Okay, by default, this is the namespace into which now if I create any object in Kubernetes, that gets added in the default. And then project 1 work చేస్తుంది. All the objects of project 1 in default. Project 2, all the objects of project 3 to default. Project 3, all the objects of project 3 into default. So now, this should not happen, or this is not ideal to maintain everything in the default namespace. Now, if you want to maintain your objects, your projects in a separate namespace, then what to do? You have to create your own separate namespace. So, how to create a namespace? kubectl create ns my ns, or let's say my project 1. We created our own namespace, my project 1. My project 1 namespace got created. Let's confirm kubectl get all. Have a look. Oh, sorry, my bad. kubectl get ns. Just have a look. We got a default. 18 minutes ago, it got created. Kube node leaves public system. But my project 1 and namespace of 22 seconds ago got created. Now, anytime you create any object in Kubernetes, so there are a lot of objects in Kubernetes like pods, replica sets, replication controllers, deployments, right? Next, daemon sets, volumes, persistent volume claim. There are different objects satisfying different functionalities to make your application highly available. So when you create objects of different types, now you have to ensure that the objects of project one to be added to a namespace by project. Later, then by default, all these are added into a default namespace. Okay, you have to ensure that you create multiple objects in Kubernetes, and all the objects are added to your namespace. And what are the command you write? The Kubernetes cluster, what are the objects present, or what are the different objects present if you want to write a command here? kubectl get all in a command. kubectl get all. What are the objects present currently in this server, in this cluster? If you want to find, you got to write kubectl get all. And guess what happens? E command put a default namespace operations. Meaning, if you write a command kubectl get all, you get response from the default namespace. Any command you write, default is the one that gives you the response. And say now, in a default namespace, there is a service named Kubernetes. Default namespace lo manaki Kubernetes ane oka default service, that is it. Other than that, nothing. But you're not getting response from everything here, or all the namespaces. You could put a default and respond. Okay. By default, there is a service available. Now, what are the objects present in kube node leaf public system? kubectl get all minus n and say my project one. You know, the objects. No resources found in my project one namespace. If we go with kube node leaves. And other than default namespace, there is an object, an namespace not to be information kavalante, you have to exclusively specify minus n and that namespaces. Later on the matram, everything gets added into the default. But any command you write, every command, the information you retrieve from a default namespace. See, kube node is nothing presented. Now minus n kube hyphen what's it? Public. Surely, no response. Even here, you don't find anything. No resources found. Now, if we go say kube hyphen system, here we go. Here we find a lot of objects present there. So when you convert the objects, what are the different objects present here? Here objects are first step. Pods. Okay. Next, deployment, replica setting, right? And let me just run the command and say less. Yeah. Pods together. Service. Next, daemon sets. Daemon set.apps, daemon set.apps, daemon sets. Next, we got deployments. Next, we got replica sets. That is it. So we found pods, replica sets, daemon sets, and deployments, and services. Service object also we found. But there are a lot of other objects too, which we have to experiment. And a discussion here, a object everything leads to high availability, making your application timely available, no downtime. But by default, these are all the objects present in a kube system namespace. Mana kubectl get all and from where we get the response? From the default. From the default namespace. Object కూడా అనేది ఏదైనా క్రియేట్ చేసినప్పుడు మనం -n అని చెప్పి ఇవ్వకపోతే డిఫాల్ట్ గా వెళ్ళిపోతుంది. బై డిఫాల్ట్ దిస్ ఇస్ వన్ ఇండివిజువల్ కమాండ్స్ ఏది రాసినా కూడా డిఫాల్ట్ ఉంటుంది మనకి రెస్పాన్స్. See, kubectl get pods already command from the default namespace. See, no resources found in default namespace. kubectl get pods -n kube hyphen system. If we only pods list out there from the namespace, Cube system. The cube system means system మనకి ఎన్ని pods ఉన్నాయి. Sorry, did I say all? Get pods కదా మనం అన్నాం. Yeah, that's it. kubectl get pods, and these are all the pods available in the get pod namespace, right? So, yeah, friends. Next, in namespace create చేయడం చూసాం. Now you tell me. Let's put it this way. I created a namespace, and in that namespace, I added multiple objects. Let's say my project in this. My project name is this, and I created a pod, pods for my project namespace. Likewise, some replica sets, replication controllers, deployments, and let's say daemon sets and services. Maybe some jobs, cron jobs, etc. These are all the objects I created for my project namespace. There are multiple objects created for my project namespace. After creating everything, I would say, let's say, kubectl and let's say whatever listed here, these are all the objects we created in my project one. Now, if I delete the namespace, what do you think? What's going to happen? kubectl delete namespace, my project one. My project one namespace is deleted. What does that mean? What does that mean? Everything gets. That's it. Everything gets removed. మొత్తం మీరు క్రియేట్ చేసిన అప్లికేషన్ పాడ్స్ రెప్లికాస్ replication capabilities, everything gets compromised. Meaning easy to handle your projects. Unnecessary projects can easily kill them when you go with the namespace. Okay. So friends, this is a quick concept about namespace. Tomorrow we will talk about pods. What is a pod? A basic building block in Kubernetes. Pod is termed as a basic building block in Kubernetes. Until మీరు Docker Swarm to create చేసినట్టు Docker Swarm to మనం ఒక container application create చేయాలంటే what is the command we learn? Docker Swarm లో ఒక container application create చేయాలి. Yeah, online candidates, what is the command? ఏదండి? Manager worker 1, worker 2, and worker 3. Now I want to create a container application in Docker Swarm where the container application should be accessible across the entire cluster. So did we go with the command docker run? Docker run to create a container docker run to create a 100% sure. Yeah, online candidates. ఏం మాట్లాడలేదండి పట్టుకున్నారా? How did we create a container application in Docker Swarm so that the application is accessible for the entire cluster? We మాట్లాడుతుంది Docker Swarm. Docker run కాదండి. We used to go with Docker service create --name svc1 right -d -t 7070 mapped to 88, let's say Nginx. Now a container application gets created. దానికంటే ముందు ఒక సర్వీస్ క్రియేట్ అవుతుంది and the service has an IP address 7070, meaning with manager IP 7070 you access this application. Slave 1, slave 2, slave 3. ఏ IP address తీసుకున్నా కూడా sorry ఏ సర్వర్ కి మీరు ఈజీగా can access this application on 277. We haven't created with a command docker run. Docker run a container only in that machine, not to the cluster. So now, when you create something in Kubernetes, what should you do? You cannot create a container directly in Kubernetes. Remember, in Kubernetes, we cannot create a container directly. There is a basic building block in Kubernetes called pod. There is a basic building block, which is termed as a pod. You have to create a pod. Docker's formula name, you cannot create container directly. You have to make sure you create with a command Docker service. Docker service creator. Now coming to Kubernetes, you have to create something called a pod. This is the basic building block in Kubernetes. A pod is a basic building block in Kubernetes that allows you to say maintain your application, that enables high availability of your container application. If a Docker service creates them, if you delete a container, what happens? Docker service container creates across the cluster. So the container application is available here. You went to this container server and you deleted it. Now what happens? Again, a container gets created. Again, you killed it. Again, a container gets created. Again, you deleted it. Again, it gets created. Right? Because a service ensures that your container application is always available. Likewise, now a pod in Kubernetes. Kubernetes lo kuda manaki entante we want the container application to always be available. So for that, you cannot create a container directly. You have to create something called a pod, and in that pod resides your container application. Your container application is residing inside a pod. Okay. So a pod acts as an outer layer to secure your container. So even a container is deleted, what happens? A pod ensures that the container is again recreated. You stop your container. Again, a pod ensures that the container is running. So we'll talk about this in detail the next slides. Today, Kubernetes is slow and more information at the same time, you get exhausted. So initially we go slower. Later on, I'll take some extended classes. So that is all, friends, about Kubernetes. And ఇంకొకటి మీరు క్లస్టర్ ఫామ్ చేసుకున్న తర్వాత let's say at Google Cloud level, what should you do? You have to delete your cluster. మనం AWS లాగా స్టాప్ చేస్తే సరిపోదండి. We got to delete the cluster. So I got to jump to my Kubernetes clusters here. And what should I do? We got to go here, select it, delete it. Delete. Delete చేయకపోతే వాటి చార్జెస్ గూగుల్లో ఇది ఒకటి ఉంటుంది. AWS లో మనం స్టాప్ చేస్తే పర్లేదు కానీ no, even AWS they charges you. Say if you create a T2.medium, T2.medium అంటే 2 GB RAM, 2 CPUs, 2 CPUs and 4 GB RAM. మరి మీరు ఈ రిసోర్సెస్ ని బ్లాక్ చేస్తున్నారు కాబట్టి even AWS they charge you if you stop your service. You have to, అంటే రన్నింగ్ లో ఉంటే ఇంకా ఎక్కువ అవుతుంది, స్టాప్ చేస్తే తక్కువ చార్జ్. So that is where you have to delete your clusters once you are done with your practice. కాకపోతే Google Cloud ఎందుకు అంటున్నారంటే just in case we tend to forget things. మనం మర్చిపోయినా కూడా మనకి $300 క్రెడిట్ ఉంటుంది కాబట్టి we can easily manage it. You don't get overly charged. Over charges అయినా మనకి mostly 150 rupees. Right? Mostly 250 rupees. ఈ అమౌంట్ వస్తుంది. But for the first month, second month, I can guarantee you that you won't get charged. Fine, we'll continue tomorrow then. Thank you. Thank you. ఇదండి మళ్ళీ టెంపరేచర్ 90 degrees. AC